right, so we're going to finish up this week looking at section 5.4. Okay, 5.4 is on logarithmic functions. Okay, and from what we did last time, this is the inverse. Okay, this function is the opposite of an exponential. Okay, logarithmic functions are the inverse of exponential functions. Okay, so if exponential functions grow super fast, what do you think is going to happen with a logarithmic function? It's going to, well, it's still going to grow, but it's going to be what? Very slow. Okay, if exponential functions are the fastest growing, these are the slowest growing. Very, very slow. Okay, in fact, when you let x get out to the thousands and even tens of thousands, sometimes y is only at like 3. All right, so you got to go really, really far out to get big values for y. Okay, inverse functions are basically mirror images. Okay, but they're not mirror images over the x-axis or over the y-axis. They're mirror images over the line y equals x. Okay, so what I've drawn here is the line y equals x in black. That's a line with a slope of 1, and it goes through the origin. Okay,
so it's like a diagonal reflection.
Yeah, it's like a diagonal reflection. Okay, what I have in blue, that's an exponential function. Okay, notice it's curving up very sharply. What I drew in red is a logarithmic function. So if you were to take what's in blue and flip it over that diagonal line, what's in blue would land exactly on top of what's in red. Okay, does everybody see that these are mirror images of each other? Okay, and if you notice before I drew this red line in, the calculator didn't sketch it. It should be there. Okay, the reason the calculator doesn't sketch it, and we saw some of this yesterday, if it starts to get too steep, it can't do it. Okay, so when lines start to approach vertical, the calculator just can't figure that part out. All right, but that's how a log function should look. Okay, and there are no horizontal asymptotes. Okay, you might think, does it level off? No. Just like the exponential, there's no vertical asymptote. It does keep going to the right, very, very, very slowly. Okay? Logarithms keep going up, very, very slowly. Okay, any questions on that one? All right. So this is how we write a logarithmic expression, okay, and how we pronounce it. Okay, this says y equals log base a of x. Okay, and if you were doing it on lined paper, okay, this is how you would write it. Log base a of x. Okay, the x is not an exponent. The x is right on the line. It's the a, it's actually below the line. An exponent would be like this. Log base a of x squared. Okay, so there's no exponent the way that's written. Right, so you can say y is log base a of x or y equals log base a of x. Same thing. Okay, that's how you pronounce it. And x, okay, that's called the argument to the log function. Okay, the argument is the thing that you plug into the function. Okay, like if I wrote something like this, we could call 3 the argument. It's the thing I'm taking the square root of. Okay. When we get to like sine and cosine, we'll have things like this. Say sine of 30 degrees. 30 degrees is what I'd be taking the sine of. It's the thing I'm plugging in to the sine function. Okay? So in this case, x is what you plug into the log function. Okay. If the base is 10, okay, we use that one a lot. So that's called the common log. It's one of the 2 bases your calculator can do just by pressing a single button. The calculator can only do certain bases directly. Okay, there's a way to do other bases indirectly. I don't think we're going to get to that today. All right, but if you want to do a base 10 log, your calculator can do it, and that's called the common log. If you want a common log, the button is right next to 7. If you press that, that's the common log. And you could type in any positive number that you want. You can't do 0, and you can't do negatives. You can try, but it won't work. It says the answer is not real. So if it's not real, what would it be? It would be imaginary. Okay, we're not doing imaginary logarithms. Okay, so make sure you plug in numbers 0 or higher. Okay, what's 5 called in this case? It's the argument. It's the thing that I took the log of. Okay? If you just type log and you hit enter, you can't do it. It's like if I put this on a test and said, what's the answer? Square root. Well, square root of what? You've got to put something in it. Okay, since we use common log a lot, sometimes a little bit shorter notation, we don't put the base. So anytime you don't see the base, you always assume it's 10, okay, or the common log. Okay, so you could see something like this, or you could see it like this. Those two things are exactly the same. Okay, kind of like in Algebra 1, if we just put a variable, there is a number that we assume that's there, even if we don't write it. Yep. So with logs, there's a number we assume that's there, even if we don't write it, and it's 10. Okay. Any questions on that? So there's one other special log the calculator can do. We talked a little bit about this yesterday. And this is when you have a base of e. Okay, so base 10, that's good common log. Base e. Does anybody remember what I said yesterday? The name of that was?
Natural log.
Good, very good. Natural log. Okay, so you have common log. When you have a base of e, this is called the natural log.
Plus
Okay, and because we use base e a lot, there's also an abbreviation for that. Okay, it's called natural log. So what we can do, instead of writing log base e of x, which is fine, but most people don't write it that way, they use this abbreviation, ln. Okay, why it's not NL, natural log, why they switched the letters, that's just the way it is. Okay, so we use ln as a short way of writing log base e. All right, so if you see a log base e, it's exactly the same as ln. So if I wanted to write log base e of 2, I could just write ln of 2. It's the same thing. Okay, what you got to be careful about ln is remember what the base is. This abbreviation hides the base. Okay, the base is e, even though you don't see it when you use the short way of writing it. Okay, same with common log. It hides the base, but you have to remember that it's a 10. Even if you don't see it. Any questions on that? Okay. That you also have a button for. It's right below the log button. Okay, so if you press ln, type in a number. In this case, I'm typing 6 as my argument. That's the answer. Okay, same deal with as log. You can't do 0. Okay, if you try, it won't work. And you can't do negatives. Okay, but you can do any number that's greater than 0. Decimals are fine too. All right, so domain, I already mentioned this to you. The domain is any number from 0 and up. Okay, you can't, I'm sorry, it's higher than 0. Okay, don't include 0. Okay, and the range, well, we already looked at the graph, but let's just take one more look at it. I'll type in log of x. Okay, I could do log, I could do ln, it doesn't matter. They both have the same domain. They both have the same range. Yeah, I'm going to do zoom 6. Notice it starts at 0, it only goes to the right. Let me let x go all the way out to 500. Notice, even if I let x go to 500, y didn't get that high. Okay, y's up maybe around 2.5, somewhere around there. Okay, even if I let x go all the way to 50,000. Look at how slow this grows. Okay, we're looking all the way out to 50,000. X isn't even up to, y isn't even up that high yet. Okay, so this grows very slowly. But if I let x go forever, how high would it go? It will go to infinity, very, very slowly. Okay, so my range is negative infinity to infinity. Again, it doesn't look like it, but remember, it should drop straight down. Okay, and you can always check that by typing in something extremely close to 0. Okay. The closer of a number you type to 0, the farther down on the y-axis that you go. So if you type in 0.00000000001, I got negative 16 for y. So it's dropping down. Questions on the domain or range of log functions? All right, so one of the most important things we're going to do is we're going to use this to solve problems like this. If I said to you 2 to what power is 10? Well, you could say, well, 2 to the 3rd power is 8. That's too small. 2 to the 4th power is 16. That's too big. So we know what the answer is between, somewhere between 3 and 4. But if we can change this to a log, we can solve it. Okay, very, very easily. Okay, so here's our formula to change between log form and exponential form. Okay, there's 3 things. Okay, and I tried to color code where things go. Right, so I'm going to start with A. And remember, it's got to be a positive number. No negatives, 0. Can be fractions, but no negatives. All right, so if we look at A, what is this called? So x is my argument. A is my base. Okay, A is my base. When we rewrite it as an exponential, A is still the base. Okay, the base is the number that's lower than everything else. That's the base. Okay, the next thing I'm going to look at is the y. Anytime you have a logarithm, okay, I'm going to say this a bunch of times today, logarithm equals exponents. That's what a logarithm is. A logarithm helps solve for an exponent. Okay, so logarithm equals exponents. In fact, let's write that down. So, logs are exponents. Okay, so logarithm equals the exponent, so y is going to become my exponent. Now, if you can figure out where 2 out of 3 things go, you figured out 2 things. There's only 1 spot left, and that's where the argument goes. All right, so we'll practice converting it both ways. Okay, but does everybody have this formula? All right, so this is log form. Okay, you know that it's in log form because it's got the word log. Our goal is to change it to exponential form. Okay, or you could call it an exponential expression, exponential equation. I'm not going to be picky about that. All right, so let's start with our base. Shannon, what's my base here? 3. 3 is my base. Okay, next thing I want to do is find my exponent. And what did I say earlier? The logarithm always equals the exponent. Okay, so what's my exponent here? Y. Okay, logarithms always equal exponents. Okay, what's the last thing I haven't used? X, and that's the only spot for it to go. That's our answer. Now this problem we can't solve because we don't know y. If I knew y was 2, then I could plug it in, 3 to the second power, and get an answer. Okay, but that's all we can do with this one. Okay, let's try this one. Tyler, what's my base here?
Isn't it 5?
Yep, base is what's lower than everything else. 5. Okay, and Nick, what about my exponent?
X.
So we said logarithm always equals what?
Oh,
And what is that? I know it's y, but it's my exponent. Okay. Logs are exponents, or you could say logs equal exponents. Okay? So the logarithm always equals your exponent. Okay, and the last thing we haven't used, x. Again, we don't know y, so there's nothing we can do to simplify this. If we knew y, then we could. Okay. Okay, any question on that one? Changing log to exponential. Okay, let's try it the other way. I'm going to change from exponential to log. Well, if we're going to put it in log form, what do you think the first word we should write down is? Log. The word log has to be in the answer somewhere. Okay, first thing I want to do is try to identify my base. Derek, what's my base here? 1.2. Okay, it's the number that's lower than everything else. And Tommy Lee, logarithm always equals what kind of number?
X, or no, y, so it would be 3, right?
Yeah, logarithm always equals your exponent, which is 3. Okay, what's the only thing I haven't used? Well, in this problem, it's m. Yeah. So this is 3 equals log base 1.2 of m. Okay, questions on that one? All right, let's try another one just like that. This one says e to the b equals 9. Okay, Paige, since I'm changing it to log form, first thing I should write down? Log. Yep, put the word log. Next thing I want to do, identify my base. Okay, Brian, what's my base here? E. Yep, it's the number that's below the exponent. E. Okay, and Matt, logarithms always equal what kind of number?
Exponent.
The exponent, good. And the exponent here? B. So we got B. I've used the E, I used the B. The only thing left is the 9. That's the only spot it can go. Now, this says log base E. We talked about that earlier. What's the short way of writing log base E? So you could write this. Okay? You just need to understand those are the same thing. And if on the test they said round that to 2 decimal places, well, you could just type in ln of 9, and it's about 2.1 or 2.20. Okay. Hey, any question on that one? Okay. Does anybody need to see another one changing exponential to log? No? Okay, so you got two of each type. All right, this one, I just want to show that what's on the left and what's on the right are the same thing. Well, up to right now, there's only one thing we know how to do. Is this log form or exponential?
Log.
It's log. So what can we do with it?
Turn it into exponential.
Yeah, change it to exponential. Okay, that's the only thing we know how to do. Okay, so let's identify, well, Shannon, what's my base here? Yep, 2. Okay, Jamie, my exponent? Okay, logarithm always equals what kind of number? Yep, logs are exponents. Logarithms equal the exponent. Okay, so 2 cubed equals, and what's the only thing I haven't used?
8.
The 8. Is that true? Is 2 cubed equal to 8? Yeah, then we just showed that what's on the left and what's on the right, they are the same thing. Okay, so any questions about what your base and what your exponent are?
What would you call 8 then if it's not an exponent?
8 in this case, what do we call this?
The argument.
That's the argument.
Okay.
Yep, that's the argument. Okay, and then when we rewrite it, it's just the number on the other side. There's no name for it. Okay, other questions on that? Okay. I don't know why it's fuzzy and then it clears up. It's kind of weird. All right, so this one, it doesn't say show it's true because they're not telling you what it equals. You have to find what this equals. Okay, so it's in log form. Only thing I can do is what? Yeah, let's change it to exponential form. Okay, what's my base here?
5.
Yeah, 5.
X.
5 to the, that's my exponent. And what goes on the other side? 1 over 25. All right. So if you're stuck, you're not sure what that would be, I want you to think about this one. What would the answer be here? 2. Right? 5 to the second power. 5 times 5 is 25. So now, we don't want 25, we want to have 25 flipped. So what kind of exponent number causes things to flip?
Negative.
Negatives. Okay, so instead of the answer being 2, you want to flip it, so you make the exponent negative. All right? If you can just see that in your head, you don't need to do what's on the right. Just trying to make a connection between the two. Questions on that one?
What if you raise it to the 1/2 power?
To the 1/2 power?
Yeah.
We talked about that. What does that do?
It makes it negative.
If you raise something to a 1/2 power, that's a square root. So that's a totally separate thing. Yep. That's from, I think, Monday. Still important for the test, though. And it's actually still important for what we're going to do today. That idea is going to come up in a minute. All right. So now they're asking us to solve. This time, look where the variable here was in exponential form. Okay. Now we're going to solve something in log form, where the variable is my argument. Okay, so Amanda, what's my base? 5. What's my exponent? 1.5. And what haven't I used? X. Just type that in. That's the answer. 5 to the 1.5 power. Okay, 11.18. Okay, so any question on solving a log equation where the variable is the argument? Okay, so there's a lot of stuff in this section, but it's a lot of simple kinds of things. Okay, but you can always put this on a reference sheet for the test on Friday. Okay, now we're going to solve one where the variable is in the base. Okay, now it's not the argument. All right. So Fernando, what's my base here? X. What's my exponent?
2.
2. And what's going to go on the other side? 3. Okay, now this one's a little different. Okay, we got to get rid of this exponent of 2. So how do I do that? Yeah, take the square root. Okay, now normally when you take a square root, how many answers do you get? 2. But what did I say about logs? They can't be negative. Okay, they always have to be greater than 0. Okay, so the square root of 3 is about 1 point, typing in the answer, about 1.73. Okay, so that's solving a log equation where the base is a variable. Okay, questions on that? All right, so last part of class we're going to do is look at some special properties with logs, and we're going to look at how we can take logs and combine them. Okay, it's kind of like if you take 3x plus 2x and get 5x. It's like combining like terms. Okay, so we're going to look at that. All these properties that I'm going to give you only apply if a is greater than 0. We already talked about no negatives, and it's not equal to 1. All right, the first one. The first one is basically a special pattern. Okay, and what we're looking for here is we have a base that's a, and we have a base on a log that's a. If those two things are the same, what happens is that part basically cancels itself out, as long as these numbers are the same. And the answer that you get is whatever's sitting right there. Okay, so a problem you might see, 4 to the log base 4. I've got to make those match to use this property of 6. Okay. What would the answer be here? 6. If these two things are the same, it's like they cancel each other out. And the answer is whatever is right there. That's it. So the answer is just 6. All right, so there's no real algebra to do. It's just recognizing a special pattern. That's it.
If they are different.
If they're different, then you got to type the whole thing into your calculator. If like this is a 4 and this was a 5, this property doesn't work at all. These are all going to be very, very special properties. Okay, here's another one, a little different. This time, the base on my log and the base in my argument match. Okay, if that happens, okay, the base on the argument and the base on that exponential cancel out, and the answer is whatever's right there. Okay, so you might see something like log base 5 of 5 to the 12th. Okay, what would the answer be to that one?
12.
It's 12. Okay, these two things cancel each other out only because these numbers were the same. Okay, and there's a very simple reason why they cancel out, but I'm not going to get into the proof of why. Okay. Any question on that? If you really want to know why, I can show you in like 30 seconds after. All right, this one. This says anytime you take a log and the base and the argument match, the answer is always 1. So if you had log base 2 of 2, the answer is 1. Log base 7 of 7, the answer is 1. Okay. Log base 13.6 of 13.6, the answer is 1. Okay, and this one I'll show why it's true. Okay, so I got 3 things. 1, 2, 3. Is this log form or exponential? That's log form. Okay, it's got the word log here. There's base, argument, number on the other side. What's my base?
A.
Yeah, which one? Green A or red A? The green one. So there's my base. Okay. What's my exponent? 1. Logarithm always equals the exponent.
Okay.
And last thing is my red A. All this property is saying is if you take anything and raise it to the first power, you get itself back. Okay? I'm sure everybody already knew that from Algebra 1. That's an Algebra 1 property written as a log. Anything to the first power is itself. Okay? That's all that Rule 3 says. You just probably never saw it that way before. Okay, and the last one says if you take the log of 1, base can be anything you want, always comes out to 0. Okay. And this one you could figure out why it's true just by doing what I did up above. It says anything to the 0 power is 1. Okay, any question on rule number 4? All right, so let's try a couple examples. All right, so first thing I want you to do is try to match this up with the rule on the left. Okay. Which property do you think we could use here? 1, 2, 3, or 4? No, I don't think it's the second one because the log is up higher. Yep, it's the first one. Okay. So using that first property, what would be my answer here, Cheryl? Pi. Okay. Whatever's sitting right there, that's your answer. Okay, so just recognizing the special pattern and seeing what cancels out. Okay, how about example B? That's the second one, and yep, the answer is -4. Okay, that's where the base and the base match, and they cancel out. Okay, this one a little tricky. Which property does that look like?
3.
3?
Not 3, 2.
Yeah, it is 2, but there's something here that's hidden and making it not look like number 2. Yeah, there's a hidden base. So what's the long way to write ln? Log base e. All right, so the long way to write out ln is log base e. Now write down the rest of what you had. E to the kt. Now you can see the base and the base match. Now it's just like number 2. So what's the answer there? kt, whatever k times t is. We don't know k and t, so we can't simplify. Right, so any question on properties of logs? Yep.
And what is C? Why is it that the E is up top and on the log?
This e comes from the abbreviation ln. This e comes from right there.
Oh.
Right? So this is the e that was hidden in the abbreviation. Okay, other questions on that? All right. So last thing. Okay, how we can take logs and either combine them together or split them apart. All right, here's our first rule. You can either look at it from left to right or right to left. Looking at it left to right, we're taking something that's combined and we're splitting it. Okay, and the way this works is if you have a product, okay, inside the argument, you can split it apart as a sum. Okay? Product splits as a sum. When you split it as a sum, you've got 2 logs. Notice the base on each log is exactly the same as the base you started with. The base doesn't change for the whole problem. The first argument was my first factor. The second argument was my second factor. Okay, so there's an example with numbers. If you had log base a of 4 times 5 times splits as a sum, I get 2 logs The base stayed exactly the same. 4 is my first argument. 5 is my second. Okay, this one I'll type it in and show you that it does work. Okay, so we type in log 4 times 5. Okay, we get 1.30. If I type in log 4 plus log 5, I get the same thing. Now, what base did I use? 10. Okay? I could have used any base I want. It's just 10 is the fastest one for me to type in. It's easiest to see. Now, what's 4 times 5? 20. What's two other numbers that would multiply to give you 20? So 2 and 10. So that would also work. Any two numbers that multiply to give you 20, you could split that log up that way. You could do 40 and 1/2. Okay, that would also work. All right, so any questions on splitting a product as a sum? Yep.
So A has to be the same for that to work out?
Yeah, the base stays the same all the way through the problem. Yep. All right, so this is the rule for a product. What do you think would happen when you divide? It's not going to be a sum. It's going to be subtraction. Okay, so if you divide inside the argument, you can split it as 2 logs. Just put a subtraction sign between the two. Log of the top minus log of the bottom. Okay, here's an example with numbers. I'm not going to type this one in, but if you want to check it yourself, you can. So log base A of 4/5. You can do log of the top minus log of the bottom. Does it matter when you subtract the order you do things in?
Yes.
Yes. Okay, so when you do this, make sure you put log of the top first, log of the bottom second. Don't switch it. Okay, and our last rule. Okay, last rule says if you've got an exponent on an argument, you're allowed to take that exponent and put it in front. Just like that. So if we had something like log base 10 of 3 to the 5th, because that's an exponent, and I have a log, I can put it in front. Okay, and those are the only 3 rules that you need to know to take logs and combine or split them. Okay, we'll practice as much as we have time for with both ways. Okay, so you got some examples for the test. All right, now, earlier this week and earlier today, somebody mentioned something about square root of x. How can you rewrite square root of x? X to the 1/2. Okay, so you already have that in your notes from Monday. But the reason that's important is because if this was a log, what are we allowed to do with exponents? Where can we move them? We're allowed to move them in front, as long as this was part of a log. Okay, it has to be part of a log problem. Okay. But exponents will go in front. Okay, we're not going to have like cube root, 4th root, any other roots that we did on Monday. This logs, we're just going to try maybe one problem with a square root. All right, so the directions here say basically split this log up. And it says express powers as factors. That means take any exponents and put them in front. All right? This first one does not have exponents. All right. First thing I want to do is decide, does this split as a sum or difference? This is a sum. It's 3 times x. Okay, it's going to split 2 logs. What's going to be the base on each log?
4.
4. Base stays the same all the way through the problem. Okay, first argument is going to be 3. Second argument, x. That's how you split the log. All right, let's try this one. Log base 2 of 5 times r cubed. Okay, look at the operation inside parentheses, and that tells you, is this a sum or a difference? It is another sum. Okay, it's log, yep, base is 2. First argument,
5.
and second argument?
R, and then we don't put 3 in the front of the log.
Oh, we'll do it one step at a time. So what would my second argument start out as? R to the third. Okay, and now the directions said put powers as factors. That means put it in front. So we can either rewrite it, or what I'll do is I'll just erase it and move it. Where does the 3 go? In front. And that's it. Okay. Question on that one? All right. Let's try a division. Okay, this time since we're dividing, it's going to split as 2 logs. What's symbol between them? Minus sign. Log base? 9. 9. First argument? Second? 2. That's it. Okay, we've been doing it with logs, but you can do it with ln's. It's just going to be ln and ln. It works with any base. Okay, I told you that earlier. Okay, addition or subtraction? Subtraction. Anyone think they can tell me the whole thing? And just be careful about one thing there. Yeah?
3 log e minus log e8.
You know what? Let's just use ln. We'll use the abbreviation.
Oh.
So 3.
Log e.
So what is log base e equal to?
Whatever. Log e equals
ln. So we're going to write that.
whatever.
So 3 ln. This would have been an exponent on what letter? Y. Minus?
Minus I8.
ln. That's okay. Okay? So this 3 went in front because it would have been y cubed. And then it goes in front. Okay? If it's ln, just leave it as ln. If it's log base 9, leave it as log base 9. Okay? Whatever you see, just copy that. Okay, and let me make up one more. Let's do. You could, but I gotta do one with a square root. All right, you know what? We'll go right to that one. Okay, it looks hard, but it's really not any harder than the previous ones. Just one step at a time. Okay. First thing I see here, we've got a fraction bar. Anytime I've got a fraction bar, get rid of that first. Okay. How does a fraction split? Is that addition or subtraction? Subtraction. Log of the top minus log of the bottom. Okay, just start with that. Okay, so log base A, square root of x squared plus 1. That's the top. Log base A, and now write the bottom. Because the bottom has a lot of stuff, I'm going to put brackets around it so we understand it's all together. X cubed, x plus 1 to the 4th. All right, now this part, we've got the square root. What can I do when I have a square root? This is the part that we talked about at the very end. I want to rewrite it.
Can't you just put like 1/2 in front of log A?
Right, because we're going to have log base A. Okay, the first step, I'm going to erase this part, would be to write it with a 1/2 exponent. But then that exponent is going to go to the front. Okay, this first part is done. There's nothing else you can do with it. So for the rest of the problem, we're just going to copy it down. We have no rule for splitting a sum. It has to be a product or a fraction. This is done. Mhm.
How about the square? Which one?
Nope, because it's part of a sum. There's nothing you can do with that. Nope. All right, now the second part. Inside here, we have x cubed times x plus 1 to the fourth. How does times split? Addition. Right? So we're going to split this as addition. So I'm about to subtract everything I split it into. It's going to be log base A. Log base A. Okay, you guys said it was addition. What's going to be my first argument? Yeah, we can start with x to the third, that's fine. Let's do the same thing here. Second argument? X plus 1 to the fourth. Okay, and now the problem is just about done. There's two things we need to do, and we already did it in the first part. Take all the exponents and put them in front. Okay, so this is the hardest they can get. They don't get any harder than this one. 3 goes in front, and 4 goes in front. Okay, so any question on splitting before we try a few combining? I think splitting is harder because you're starting out with something that's already all together, and at each step you're making it bigger and bigger. With combining, we're going to start with something that's bigger, and at each step it's going to get nicer and nicer. It's going to get more combined. Okay, so here's something that's been split. Okay, this is like the final answer in the last part. All we have to do is do everything we just did in reverse. So what's the first thing we would do here with this 4?
Put on the top of
Put it back as an exponent. Okay, the last thing you would have done is put it in front. Now you're going to put it back. Okay, so this part isn't really anything different. It's the same thing in reverse. All right, and since I have this, I might as well do it out. Okay, 3 to the 4th power, just so we don't have to keep writing it. That's 81. Okay, so I have log base A 7 plus log base A 81. I have 2 logs with a plus sign. What does that mean they were before they were split? Multiplication. Okay, the log stays the same. And what would I put in parentheses? 7 times 81, or 567. You just use your calculator. In my head, I just did 7 times 8 is 56, and 7 times 1 is 7, and I added 567. Questions on that?
This will be log A of 567.
Yes, thank you. Yeah, base stays the same for the whole problem. All right, let's try this one. I don't want to do 81. Let's make it
9.
9.
what is it?
Okay, we can make it 9. I'm not sure the answer is going to come out very nice, but we'll try it. All right, first thing I would do with this 2/3. Think about it, it's in front. Put this back as an exponent. Okay, so ln 8 2/3. This we just did. What's 3 to the 4th power? So instead of writing it that way, why don't we just do the arithmetic out? What's 81 minus 9? Okay. And now, to do this, there's 2 ways. Just type it in on your calculator. Or if you're doing it by hand, okay, what I do is block off the divide by 3. Okay, what's 8 squared? 64, and that means cube root. Okay, what's the cube root of 64? 4. Okay, I could only do that in my head because it came out nice. If you don't know how to do it, you can always just type it in. So ln of 4 minus ln of 72. Subtraction sign. How would those have been before they were split? Divided. Okay, and if they wanted a decimal, we could just type it in. ln of 4 over 72. It's about negative 2.89. Okay, questions on that one? I think that's good. All right, so homework tonight, just on logs, okay, page 292, 1 to 6, 13 to 16, okay, 21 to 23, 25 through 27, and 29 through 32. Okay, this is due on the 20th, okay, because I won't see you tomorrow. All right, so again, if you do need extra help, I'll be after school today, a little after 3 o'clock. Otherwise, I will see you on Friday, and that's when we have our test.